and that's this. I look at the highest power between the numerator and the denominator. In this case, the highest power is what? X cubed. This is a pain, by the way. So I want to take the limit as x goes to infinity of this guy, but I'm going to multiply by x cubed divided by x cubed. And in the one below it, you notice it's an x squared and an x cubed. You choose the bigger of the two, you choose x cubed. So this becomes x cubed times 1, or 1 over x cubed, minus 3x cubed times x cubed. Well, that's just 3. X cubed times 2 over x cubed, and this should be 1 over x cubed right here. Make that a 1 over x cubed. Is going to be a 2 minus 5x cubed times, or 5x times 1 over x cubed. Well, that's 5 over x squared, plus 2 times 1 over x cubed. That is plus 2 over x cubed. So now I take the limit as x goes to infinity. As x goes to infinity, where does 1 over x cubed go? Well, this would become 1 over infinity cubed, and I hate to write this because this is not a true mathematician's way of viewing it. 2 minus 5 over infinity squared plus 2 over infinity cubed. What's 1 over infinity cubed? Constant divided by infinity is always 0. 2 minus, what's 5 over infinity squared? 0. What's 3 over infinity cubed? 0. And I'm going to come down with a negative 3 divided by 2. That's his limit. Negative 3 halves. And if I take the limit as x goes to negative infinity of the same mess, oh crapola, I jumped the gun, hang in a second. Hang on. Make sure everybody had the other copy done. So it's just the same thing, negative infinity, right? Now I plug in negative infinity. This is the way I did it. I hate it. It's the way your book would do it. This is the way a pure calculus person would do it. Yes?
Is it okay if the lights can go up because I keep squinting and like I need the dark to like see better?
Let's finish the problem first.
Okay.
What's this guy? 1 over negative infinity cubed. 0. 2 minus 5 over negative infinity squared. And 2 over negative infinity cubed. So it's negative 3 halves. So that says as x goes to negative infinity, y goes to negative 3 halves. So what's this telling us? if x is going to infinity, y is going to 3/2. That's your horizontal asymptote. Negative 3/2. As x goes to negative infinity, y is going to negative 3/2. That's horizontal asymptote. It's an HA. Now that's a pain. And to me, it's way too much work to have to deal with it like that. So I mean, I can roll.
Yes.
Whoa.
Yes.
Now you can't write.
That's perfect.
And I can't change this. We're stuck with it for the moment. Yeah, I can't see. Go that way. Now, this is a polynomial. And in college algebra, we would call this, at least I call it, the end behavior model. And what it is going to be the power function of the numerator divided by the power function of the denominator. Because we're dealing with polynomials. Because who's in control in the numerator? X squared. Who's in control in the denominator? X cubed. So if I kind of look at the end behavior model, I'm going to call him EBM. He's x squared over x cubed. So if I want to take the limit as x goes to infinity of x squared over x cubed, this becomes the limit as x goes to infinity of 1 over x, which is 1 over infinity or 0. I would get that same impact of essentially 1 over x if I were to divide the numerator by x cubed. What would I get? I'd get 1 over x plus 1 over x squared minus 5 over x cubed. That's all going to 0. Well, we'll take a look at that. And if I take the limit as x goes to negative infinity of x squared over x cubed, it's the limit as x goes to negative infinity of 1 over x, which is 1 over negative infinity, and 1 over negative infinity is 0. So it has an HA of 0. What I was talking about earlier is if I had to do it the way your book would do it, or a traditional calculus book would do it, you multiply both numerator and denominator by 1 over x cubed. So that becomes x squared over x cubed minus x over x cubed minus 5 over x cubed, 1 over x cubed minus 2x over x cubed minus x cubed over x cubed. This is 1 over x minus 1 over x squared minus 5 over x cubed divided by 1 over x cubed minus 2 over x squared minus 1. Now what you notice is, if I take the limit as x goes to infinity, what happens? This guy goes where? 0. That's 1 over infinity, or 0. This guy goes where? 0. This guy goes where? 0. So that says I've got 0 in the numerator. This guy goes where? This guy goes where? And then this guy goes to negative 1. You got 0 over negative 1 or 0. I'd rather use the model because who's in control in the end are the two highest powers. And that takes this whole messy thing out of the way. If you want to do it that way, I am fine with that. That is traditional. That's the way I learned how to do it. To me, I'm too lazy.